All right, boys and girls, here we are, starting chapter 3. And there are 8 chapters, or 8 lessons in chapter 3. And we get to start doing stuff that I love to do. We're going to graph lines, and we're going to write equations, and we're going to do all that fun stuff. Today, however, in their first lesson, it starts off pretty slow. We're just going to talk about what makes it a linear relationship, and then more importantly, and just as importantly, I guess, what makes a linear relationship proportional. So relationships that have straight line graphs, that's what makes it linear. So if you're looking at a graph, super easy. It's a straight line or it's not a straight line. If it's a straight line, it's linear. If it's not linear. Okay? But if it's a straight line, that means there's the same rate of change. We're going to talk a lot about rate of change. So that means if I pick 2 points anywhere on that line, the rate of change is the same. And if something is the same, we say it's constant. Like you're constantly annoying me, it doesn't change. Okay, so if it stays the same, it's a constant rate of change. How are they changing? Okay, well, slide over. We got a couple things to fill in on slide number 2 to the right. Something is linear if it forms a straight line on a graph. If it forms a straight line on a graph, or if it's linear, that means it has to have a constant rate of change. Meaning it's the same. So how do we check it? Well, like I said, if it's on a graph, it's a straight line, period, done. Your hands are washed, game over. But if we're looking at a chart, remember I'm going to talk about the outside ratios. That means, and I'm going to show you, we're going to count how many the X changes and how many the Y changes every time. And if it has a constant rate of change, aka it's linear, okay, on a graph, we're going to use 2 points. Okay, lines can create a positive constant rate of change, meaning as it goes to the right, it goes up. Or a negative rate of change, which just means as it goes, to the right, it goes down. Or down to the left, up to the right, down to the left. That's a typo. Down to the right. Okay, so let me show you what that looks like. If we're looking at a graph, straight line. If we're not looking at a graph, like in example number 1 on slide 3, we are talking about the balance in an account. So if you have money in an account, how much money is in there is called the balance. Okay, after several transactions, whether you're taking money out or putting money in, is the relationship between the balance and the number of the transaction linear? If so, they're going to always ask you to find the constant rate of change. Okay, so it tells you exactly how to set it up. The wording, the relationship between the balance and the number of transactions. The balance goes on top over transactions. So we're going to look at the balance. What's happening here between these two? 70 to 40, that's a negative 30 because it's going down 30. 40 to 110, that's also a negative 30. And 110 to 80, negative 30. Okay, take a look at what happens on the number of transactions. That's the X, but it's going to go on the bottom. That's plus 3, that's plus 3, and that's plus 3. Is it a constant rate? Negative 30 over 3, negative 30 over 3, negative 30 over 3. Yes, it is. Every single one is negative $30 over 3 transactions. So the rate, if we simplify that, is negative $10 per transaction. Okay, that means on every transaction, it's going down $10. The negative here just means it's reducing by $10 every transaction. So yes, this is linear. And here's my constant rate of change. Okay, let's try another one. We have two examples on the next slide over here. We have an example in A, again, of a table or a chart. So the Y, change in Y, that's always this one over here, the second one or the bottom one. Right here, let's see, it's going down 5, and then it goes down 4. So notice when it's going down, I am showing that with a negative. And over here on the time, the X, that's plus 5, plus 5, plus 5. So I got negative 5 over 5, I got negative 4 over 5, and negative 4 over 5. Are they the same every single time? The answer to that is no. So this is not linear. And the reason why? Well, pretty simple. Not a constant rate of change. And I will even let you abbreviate like that. Okay? So table. Look at letter B. Now, if I'm looking at that graph, that looks like a pretty straight line. Okay? It looks pretty straight. It changes the same every single time. So yes, it's linear, but we have to also give the constant rate of change. So let's pick 2 points. Doesn't matter which two. These are all pretty nice and friendly points. Okay, so this one is 8, 80. This one is 16, 60. Okay, so change in Y is down 20 minutes, and change in X is up 8 volunteers. In other words, if I divide that out, 8 doesn't go into 20, excuse me. 8 doesn't go into 20 minutes, but we can sort of simplify it out. What can we reduce by? We can take a 4 out, so 5 minutes for every 2 volunteers. And if I were interpreting that, what does it say? If we're talking about the minutes going down with the number of volunteers, I'm going to go out on a limb and say they're probably talking about a job to do, and if the more volunteers they have, the more the time is going to go down, which makes sense. If you have more help, it takes you less time usually. It's going to go down by 5 minutes every 2 volunteers they add to the job. That makes sense. So linear, and there's my constant rate of change. Okay, you will have questions like that. Turn it over. Got a long lesson here today. I guess it's not that long, but we got a lot to talk about. So, just because something is linear does not mean it's proportional. A proportional linear relationship, that means not only must you have a constant rate of change, but for every point or every ordered pair, if I put them in a ratio, they need to be the same. So it means a constant rate of change. So the outside ratio, that means it's linear, but it also needs to go through the origin. That means through 0, 0. So if we're on a graph, it's really easy. Does it go through the origin? Or does it not? If it does, it's proportional. But if we don't have a graph, then we check each ordered pair and put it in a ratio. We put the Y over the X. It has to both be linear, and the constant ratio has to be the same. So let me show you what that looks like if we're looking at a table and not just a line on a graph. Okay, first of all, here we are, we're looking at the degrees Celsius and degrees Fahrenheit. Remember, this is the X and this is the Y. So is it linear? Well, let's look. Constant rate of change, we've got Let's see, 32 to 41, that's plus 9, 41 to 50, plus 9, 50 to plus 9, plus 9, and this is plus 5, plus 5, plus 5, plus 5. So is it linear? Yes, the constant rate of change is 9 degrees Fahrenheit over 5 degrees Celsius. Okay? Now, to see if it is proportional, we have to check the constant ratio. We've got a constant rate of change, 9 over 5, 9 over 5, 9 over 5, 9 over 5. But the proportion, the ratio inside, we actually have to put the y over the x. So we have to put 32 over 0. And I'm getting that right here. 41 over 5. 50 over 10. 59 over 15. I'm taking the actual ordered pairs. And are they the same? Are they equal? Well, right off the bat, I'm looking right here, because 5 over 10 is 5. 41 over 5, that is, 5 over 10. Yeah, 5 over 10 is 5. 41 over 5, that is definitely not the same thing. They are not equal. So it is not proportional. It's still linear, but it is not proportional. Okay, and here's my work, because it is not a constant ratio when you're putting the ordered pairs over there. All right, so slide down to number 7. All right, we have a graph. We're looking at the graph. And when they give you graphs that are kind of goofy like this, and it's hard to estimate it, notice they're giving you the ordered pairs right there. Okay, so is it linear? Well, does it make a straight line? Yes, it does. The constant rate of change? Well, let's see. Pick 2 points. Doesn't matter which 2. I'm going to go 0, 32, and 5, 41. What is the change in the y? That's 9. The change in the x is 5. So constant rate of change, 9 over 5. But it's not proportional. I don't even have to check that, because I can look over here and say, well, it's not going to go through the origin because it's going through 0, 32. It doesn't go through 0, 0. So no, it's not. Why? Does not go through origin. Now, I can say that on this problem because I actually have a graph to look at. If I don't have a graph to look at, I can't say it doesn't go through the origin, not unless you graph it. And if you graph it, you better show me the graph. Okay, slide over, letter C, slide number 8. We've got a table. Use the table to determine if there is a proportional linear relationship of an object in kilograms and in the weight. So let's take a look at our outside ratios, our constant rate of change. That's plus 9, plus 9, plus 9, and up here we got plus 10, plus 20, sorry guys, plus 20, plus 20. So is it linear? Yes. Our constant rate of change is 9 kilograms over 20 pounds. Change in y over change in x. 9 over 20, 9 over 20, 9 over 20. They are all 9 over 20. Now, is it proportional? I don't have a graph to look at, so I can't see if it goes through the origin. But maybe I could. If you guys followed this, well, you know what? Let's skip that. Let's just put 9 over 20, 18 over 40. You guys see where I'm getting those? Right here. I'm putting y over x. So the next one's 27 over 60 and 36 over 80. If we reduce these to each one of these, and you could even punch into your calculator and see if you get the same answer for each one. And if you do that, you will see that you do. So, is it proportional? Yes. Why do I know that? All Ratios are constant. It will go through the origin. But check this out up here. If I work my way backwards, wouldn't the original one be 0, 0? It would. That's just one more trick. Okay, just one more trick. So it is linear and it is proportional. Okay, slide on down. Let's try another one here. The altitude, that means how high an airplane is after a certain number of minutes. The altitude, y, minutes, x. Is the relationship linear? If so, find the constant rate of change. If not, explain your reasoning. And then I'm also going to ask you to tell me whether or not it's proportional. I know it doesn't have that in the graph, but that's fine. So is it linear? Well, look. Is it a constant rate of change? It's definitely going down, which makes sense. The longer it's in the air, well, kind of makes sense. It must be landing, hopefully, because it's going down. So let's see there. Would you say that is a straight line? I would say that's pretty darn close. The constant rate of change. Well, let's see. This one would be about 3,500 at 0 and 3,000 at 2 minutes, which means it is negative 500 feet per 2 minutes. And if I reduce that, negative 200 feet per 1 minute. That's my constant rate of change. Now, is it proportional? I hope you can just look at that graph and know the answer to that is no. Why? Because it does not go through the origin. It does not. It does not go through here. It is not proportional. Okay? Your assignment is actually out of the textbook today. If you miss class, we're going to do a bunch in class. If not, get started on that. Make sure you're labeling what page and what numbers. Omit means you get to skip number 12. All right, we're going to review this again in the next class period, so hopefully it goes all right. Otherwise, good luck, and I'll see you in a day or two.